Welcome back. We'll discuss application of matrices in solution of solving a non-homogeneous system of equations. Let's say we have system of equations like this: a1x plus b1y plus c1z is equal to d1. The second one, this is equal to d2. This is the third one. This is equal to d3. Let us first of all understand what do we mean by non-homogeneous system. Okay, if d1, d2, d3 are not all zeros, then we have a non-homogeneous system of equations. This system of equations, this can be written in matrix product form like this: a1, b1, c1, a2, b2, c2, a3, b3, c3. Then a column matrix with unknowns x, y and z. This is equal to the values on the right hand side: d1, d2, d3. So we can see if we multiply this with this, we get this: a1 into x plus b1y plus c1z is equal to d1. That's the first equation. Similarly, a2x plus d2y plus c2z equal to d2. The second equation and the third equation. This is matrix product form. The question is, we have to find out this matrix. Let us represent first matrix by A. Let's say this is matrix of unknowns, column matrix X. This is equal to right hand side B. So if B is not a null matrix, we have a non-homogeneous system of equations. So we have a non-homogeneous system of equations here. How do we proceed? We find out determinant of A and check if it's a 0. The answer to this could be no, that it's not 0, or it's yes, that is determinant of A is 0. If the answer is no, this means we have a non-singular matrix A. Non-singular matrix A means we'll be able to find out A inverse. So A inverse exists. The system will have a unique solution. So whenever a system of equations has a solution, we say it's consistent. So we say this system is a consistent system of equations. That is, it has a solution which is unique. So consistent with a unique solution which is given by x is equal to A inverse into B. This will give us x is equal to A inverse into B. But this is possible only when determinant of A is not equal to 0. In questions, when determinant of A is equal to 0, that is, the answer to this is yes, we have a singular matrix, and singular matrix we know is not invertible. So next we find out adjoint of A into B. We find out adjoint of A into B. Adjoint of A into B, if this is not a null matrix, then the system is inconsistent. The system of equations is inconsistent. That is, there is no solution. So obviously, we don't proceed beyond this point. We simply write the system is inconsistent. That is, there is no solution. But if adjoint of A into B is a null matrix, this system is consistent with, we can say, infinite number of solutions. Infinite number of solutions. So you should have this flow chart in your mind before you have to solve any question on system of non-homogeneous equations. Let us now try these questions one by one. This is the first one. We are given three equations in three unknowns x, y and z. So the first step is we write this as a product of two matrices. So let's write this is 5, 3, 1, then 2, 1, 3, 1, 2, 4. Second matrix containing unknowns x, y and z. This is equal to 16, 19 and 25. So obviously this is non-homogeneous since these entries are not all zeros. Again, like discussed just now, we write a into x is equal to b. Let's find out determinant of a. We can simply expand. We expand along elements of the first row. This is 5. It's 4 minus 6 minus 3. It's 8 minus 3. And plus 1, 4 minus 1 is 3. This is minus 10, minus 15 and plus 3. So this is minus 22. This is not equal to 0. Now determinant not equal to 0 means the system is consistent with the unique solution. Let's find out the unique solution. For unique solution is x is equal to a inverse into b. So this is determinant. Let us now find out a inverse. We know it's adjoint of a upon determinant of a. So x is 1 by determinant is minus 22. This is adjoint. We'll write adjoint here b. This is b. 16, 19. This is 25. So cofactor of this element 4 minus 6. This is minus 2. Cofactor of this is 8 minus 3, 5 minus 5. Let's write here taking transpose. Then for this 4 minus 1, 3. So we write it here. For this element it's 12 minus 2, 10. It's minus 10 here because of position. 20 minus 1, it's 19. Then for this it's 10 minus 3, 7. We write minus 7. For the elements of last row, 9 minus 1 is 8. This is minus 13. This is minus 1. Let's multiply. This is minus 32 minus 190 plus this is 200. Minus 80. Next will be 361 minus this is 325. Then 48 minus this is 133 minus 25. This is minus 1 by 22. This is 10 and minus 22. This is 36 minus 80 plus 36 is minus 44. And this is 158. 158 minus 48, 110. Minus this is 110. Divided by minus 22, we get 1, this is 2, and this is 5. So this is matrix x equal to. That means x is 1, y is 2, and z is 5. We can always check our answer. Substitute these values here. 5 into this is 1 plus 3 into 2 and then plus 6 z, that is 5. this is 16, so this is equal to 16. This is how we get it. Now coming to the next one. Here the unknowns x, y, z are given in the denominator. So in such questions, it's suitable if we change the variables. If we write 1 by x as, let's change 1 by x as capital X, 1 by y we take as y, and this is capital Z. The system of equations is now 2x plus 3y and plus 10z. This is equal to 4. Then 4x minus 6y plus 5z. This is equal to 1. 6x plus 9y minus 20z. This is equal to 2. We can solve it now. Let us write the system of equations, the non-homogeneous system of equations in matrix product form, like this. These are the unknowns, capital X, capital Y and capital Z here. Right hand side, it's 4, 1 and 2. The first step, we find out, okay, let us name this as A. So determinant of this matrix, this will be expanding along the elements of first row. 2 into is 120 minus 45. Minus 3 is minus 80 minus 30. Plus 10, it's 36 plus 36. This will be 150 plus this is 330 and this is 720. So that's 1200. This is obviously not equal to 0. Therefore, the system is consistent with the unique solution, which is given by x is equal to A inverse into B. Now let's find out A inverse. So this is A inverse. This will be this matrix. This is 120 minus 45. This is 75. For this element, it's minus 80 minus 30 minus 110. So I am writing here plus 110. 36 plus 36. This is 72. Now coming to the elements of second row, minus 60 minus 90 minus 150. So 150 because of position. Minus 40 minus 60 minus 100. Then it's 18 minus 18. This is 0. Elements of the third row. So 15 plus 60, 75. Then for this, it's 10 minus 40 minus 30, 30. Minus 12 minus 12 is minus 24. So this is A inverse. This is determinant. So X, this matrix containing X, Y and Z. This will be 1 by determinant, then inverse, that's 75, 150, 75, 110 minus, this is 100, this is 30, 72, 0 minus 24, into these values. This is 4, 1 and 2. This is 1200, multiply this into this is 300, plus it's 150 plus 150. Then 440 minus 100 and plus 60. Then 288 minus this is 48. 1 by 1200. this is 600, this is 340 plus 60, this is 400, and this will be 240. So this is 1 by 2, 1 by 3, and this is 1 by 5. So we have obtained values of unknowns. Unknowns here are capital X, Y and capital Z. That is, this is 1 by 2. So this is 1 by 2 means 1 by X is 1 by 2. So this gives us X equal to 2. Similarly, this is capital Y equals to 1 by 3. That's equal to 1 by Y. This means Y is 3. And similarly, Z is 5. So these are the values. Coming to the third question, we have two equations in X and Y. We have to solve for X and Y. The method remains the same. First of all, identify that it's a non-homogeneous system of equations. Let us write in matrix product form 2, 5, this is 6, 15 into x, y, and this is 7 and this is 13. It's like a into x is equal to b. We find out determinant of a. Determinant of 2, 5, this is 6 and 15. This is 0. So determinant of a 0 means that unique solution does not exist, but we may have one of two cases. Either the system is inconsistent or it's consistent with the infinite number of solutions. So this is determinant of a is equal to 0. Now let's find out adjoint of a. Using shortcut, this is 15, we have 2 here, minus 5 here, minus 6 here. And let's find adjoint of a into b. This is 15 minus 5, minus 6 and 2 into b, which is 7, this is 13. This is b, 7, 13. Multiply 105 minus this 65 minus 42 plus 26. This is not a null matrix. So if adjoint of a into b is not a null matrix, this means this system is inconsistent. That is, there is no solution. We have an inconsistent system of equations. That is, there is no solution. The next one, fourth. We are given, like before, 3 equations in 3 variables. Right hand side, all the values are not zeros. Therefore, this is a non-homogeneous system of equations. Write this in matrix product form. 1, 1, 1. This is 1, 2, 3. 1, 4, 7. X, Y, and Z. This is equal to 6, 14, and this is 30. To find out determinant of a, this is 1 into 14 minus 12 minus 1 into, this is 7 minus 3, 4, and plus 1. It's 4 minus 2, that is 2. So this is 0. So determinant of a 0 means unique solution does not exist. We have to find out now product of adjoint of a and b. So let's find adjoint of a into b. Adjoint of a, we'll write here, into b is 6, 14, this is 30. So for adjoint of a, cofactor of this 14 minus 12, that is 2. Second element, this is 7 minus 3, 4. Taking transpose and assigning suitable sign. For this it's 4 minus 2, so 2 here. For this elements of now the second row, 7 minus 4 minus 3. Because of position, this is 7 minus 1, then 4 minus 1 is 3, so minus 3 here. Next is 1. For this it's 3 minus 1, 2 minus 2, 2 minus 1 is 1. This is adjoint of A, and we have already written B here. Let us multiply to get this product. This is 12 minus 42 plus 30 minus 24 plus 84 minus 60, 12 minus 42 plus 30. We can see each of these elements is a 0, therefore it's a null matrix. So if adjoint of A into B is a null matrix, this means the system is consistent with infinite number of solutions. Now how do we find out those solutions? We consider any two equations. Let's say you consider first and second, and we put z is equal to k. Shifting k to the right hand side, we have x plus y is 6 minus k, x plus 2y 14 minus 3k. Now we have two equations in x and y. We solve using matrices only. Writing the given system in matrix product form, xy here, and right hand side 6 minus k, 14 minus, this is 3k. We check this is not 0, determinant is not 0. This is like a into x is equal to b. Determinant of a here is not 0, it's 1. 2 minus 1 is 1. So x will be a inverse into b. A inverse, this is determinant, 1 by determinant into adjoint of a. That's 2, 1, minus 1, minus 1. Shortcut method. Into b. So we write b here. This is 6 minus k, 14 minus 3k. That's x is equal to, multiply now, 12 minus 2k minus 14 plus 3k. K minus 6 plus 14 minus 3k. And that is k minus 2 minus 2k plus 8. So x means small x and y, column matrix containing small x and y. So this is x equal to k minus 2, y equal to 8 minus 2k. And we have put z equal to k. Now how do we explain the system has infinite number of solutions? Since we can assign infinite values to k is let's say 1, we will have different values of x and y. K 0, different values of x and y. K equal to 2, we will have another set of values. So since k can be assigned or z can be assigned infinite values, the system will have infinite number of solutions. We can substitute these values in the third equation. This is the third equation. X is k minus 2, 4y is 32 minus 8k, 7z is 7k. This gives us, this is 30. So this is equal to the right hand side. Okay, next one, fifth question. We are given two matrices, two square matrices of order 3, A and B. We are asked to find out product of A and B. We will find out product AB, and then hence we have to solve the system of equations. This is another question on homogeneous system of equations. We have to solve for x, y and z. Okay, let me multiply A and B. I write A here. This is AB. This is matrix A. 1 minus 1 0 2 3 4 0 1 2. B, the second given matrix. 2 2 minus 4 minus 4 2 minus 4 2 minus 1 and 5. Using row column multiplication, it's 2 plus 4 plus 0, that is 6. It's 2 minus 2 plus 0 minus 4 plus 4 plus 0. Second row, it's 4 minus 12 plus 8, 0. 4 plus 6, 10 minus 4, that is 6. Minus 8 minus 12 minus 20 plus 20, 0. Next 0 minus 4 plus 4. Then 0, it's 2 minus 2. And 0 minus 4 plus 10, this is 6. This is a scalar matrix. This can be written 6 times 1 0 0 0 1 0 0 0 and 1. This is 6i, 6 times unit matrix. This is first part of the question. Find AB. Next, hence solve means we have to use this relation to solve this system of equations. Let us write the equations. X minus y, this is 3, 2x plus 3y plus 4z is 17, y plus 2z is given 7. To solve this system, we write this in matrix product form. 1 minus 1 0, 2 3 4 0 1 2 into column matrix containing unknowns x y z equals to the right hand side matrix B. This is 7. So we have this and this is equal to this matrix. Now what is this matrix? If you observe, this is given matrix A. We have 1 minus 1 0, 1 minus 1 0, 2 3 4, this is 2 3 4. So we can say this is A into X. Normally we write A into X is equal to B, but here B is this matrix. So let us say it's a C. We find out determinant. Check that determinant of A is not equal to 0. You will check it. Then how do we get X? X is A inverse into C. Now where to use this? AB is equal to 6i. This will help us find out A inverse. So shifting 6 to the left hand side, I write B upon 6. This is equal to I. So we already know that A into A inverse is I. That is product of two matrices if it's I, each is inverse of the other. Here I want A inverse. So can I say 1 by 6 times B is A inverse? A into A inverse is I, A into A inverse is I. So this is A inverse. 1/6 of B. B is that matrix. 2, 2 minus 4, minus 4, 2 minus 4, 2 minus 1, this is 5. Into C. C is this matrix, column matrix 3, 17 and 7. This is 1 by 6. 6 plus 34 minus 28 minus 12 plus 34 minus 28, 6 minus 17 plus 35. This is 40 minus 12. 40 minus 28 is 12 upon 6. This is 2. This is minus 40, so minus 6. Minus 6 upon 6 is minus 1. This is 41 minus 17, 24 upon 6 is 4. So we have x 2, y is minus 1 and z is 4. We discuss another question. Here we have to find out A inverse for a given matrix A. After that, we have to hence solve the given system of equations. So let us follow the steps. First of all, we have to find out A inverse. Determinant of A. This is 2, minus 2, minus 2, minus 3 is minus 1 plus 6. That's 5. 1. 1 plus 6, 7. Minus 8, minus 15 plus 7. This is minus 16. So A inverse. This is determinant, then adjoint. Minus 2, minus 2, minus 4 here. Minus 1 plus 6, it's 5. Minus 5. 1 plus 6, it's 7. Second row, minus 3, minus 1, minus 4. Minus 2 plus 3 is 1. 2 plus 9, this is 11. Minus 11. Last row, 6 minus 2 is 4. 4 minus 1 is 3. Because of position negative sign, 4 minus 3, it's 1. This is A inverse. Now to solve this system of equations, this non-homogeneous system of equations, let us write this in matrix product form. 3, 2, this is 1, 1, 2, minus 1. Then x, y, z, this is 13, 4 and 8. We can say, let us see what is this matrix. We have 2, 3, 1 here. This is 2, 3, 1. 1, 2, 2 is 1, 2, 2. Minus 3, 1, minus 1. So what is this matrix? This is transpose of this A. So we write this as A transpose into X and this is B. A transpose into X is equal to B. We have identified that this is A transpose. How to get X from this? It will be A transpose inverse into B. And in matrices we have studied that A transpose inverse is same as A inverse transpose. And A inverse is already with us. Let me write A inverse minus 1 by 16, then minus 4, 4, 4, minus 5, 1 and minus 3, 7, minus 11, 1. Transpose of this into B, which is column matrix 13, 4, 8. You can take transpose. So x is minus 1 by 16, taking transpose, interchanging rows and columns. This is minus 3, 7, minus 11 and 1. This is transpose into, this is B. Minus 1 by 16, multiply, minus 52, minus 20, plus 56. 52 plus 4, minus 88. 52 minus 12 plus 8. This is minus 1 by 16. This will be minus 72 and plus 56. Minus 16, 56, minus 38 is minus 32. This is 48. So divided by minus 16, it's 1 here, 2 here, and minus 4 here. So we have x equals to 1, y is 2, z is minus 4.